Doing the next part from the electrochemistry in this particular video. I hope this is going to be a short one. In the very last video, I actually made you go through the first law of Faraday's, which is about Faraday's law of electrolysis. So what it was about, I'm just giving you a bit of introduction of that. It says that during electrolysis, the amount of substance depositing on the cathode or amount of substance liberating on the anode is directly proportional to the charge passing through the solution. So this is going to be the second video for the Faraday's law of electrolysis. So let's start with that and see what this is all about. So second law, Faraday's second law of electrolysis. So I just write second law, right? So let me write this statement and then I will explain to you what this is about. When same amount of current passes through different electrolytic solution, different electrolyte solution, then amount of substance depositing at the cathode or amount of substance dissolving at anode is directly proportional to its equivalent weight. Okay, so let me repeat the statement here and see if things are really going well. Yeah, so the thing is that the second law says, let me draw a diagram that will help you to understand exactly. Suppose there are two or more than two, you can take any number. There is an electrode here, there is another electrode here, there is third one here, and there is fourth one here. Now these two electrodes have been connected to a source of voltage. There you have the anode, there you have the cathode. So this is your cathode, and they have been connected in series. So as you can see, suppose what is happening here, this will result dissolving into the solution and this will result depositing onto the solution. This will again dissolve into the solution and this will deposit on the solution. This is about zinc, and make this one any metal like maybe copper. So this is about copper here. So what you see out here that there are two electrolytic solution. One is of zinc, other is of copper, and they have been connected in series. And of course you have to put some solution into. I hope you don't mind thinking by on your own. So what is happening here? The direction of current is here. So they are connected in series. So as per the statement, when same amount of current passes through, what that means? That in this case, I is same. When same amount of current passes through different electrolyte, so then amount of substance depositing. So the amount of substance depositing or dissolving in any of these two, they are going to be directly proportional to the equivalent weight of the element. So what that means? Not only I is same, T is also same here. T is also same. So what that means? Q is equal to I into T. So that's also going to be same. So what that means? They both are not only current being given same, not only time is being given same, but the charge flowing is also same for both of the electrolyte. So as per the statement, mass is directly proportional to equivalent weight here. Mass is directly proportional to the equivalent weight here. Right? I hope you have understand. So from the first law of Faraday, there was an equation, M is directly proportional to or M is equal to Z into Q here. Now if you remember, this was also equal to M equal to equivalent weight, equivalent weight divided by that was Faraday constant. If you remember, there was 96500, right, into Q, right, into Q. So we can write it like, for zinc, this is going to be mass of zinc liberating or depositing is equal to equivalent weight of zinc. Can we write it like equivalent weight of Zn into Q divided by F. So I'm making this one as an equation 1. Right? I have made this one as an equation 1. So similarly, for copper, what this is going to be? Mass of copper depositing or dissolving is equal to equivalent weight of copper into Q divided by F. What F is? I repeat back. F is called Faraday constant and its value is 96500, right? So make this equation 2 here. Now comparing both, what we can write like, mass of zinc depositing or dissolving, or mass of copper being dissolving or depositing is equal to mass of is equal to equivalent weight of zinc divided by equivalent weight of the copper. So this is the relation coming out to be. One last thing is that in general or simply general equation, M1 upon M2 is equal to E1 upon E2. So this is what the whole relation is coming out to be. And let me repeat back the whole thing. This is about the second law of Faraday's. What the law says, I hope let's give you some seconds so that you can make a copy of that. But okay, so let me repeat back the whole thing. What I was saying, that according to second law of Faraday's of electrolysis, when same amount of current passes through two or more different electrolyte solution, then amount of substance being dissolved or amount of substance being deposited on the electrode, they are going to be directly proportional to their chemical equivalent weight. I hope you remember what chemical equivalent weight is. Chemical equivalent weight is molar mass divided by N. What N is? N is the number of electron required for the reduction. So this is what the statement is. Mass is directly proportional to chemical equivalent weight. Now, this is about the second law. So what I have done in the next session here, next part here, from the first law of Faraday, what we remember, M is equal to Z into Q. In case you have problem understanding what this is and where is it coming from, you just need to check out the very previous video where I have described the first law of Faraday. I was thinking of making them together, but I couldn't do that. So you have to go and check out the previous video. So according to first law of Faraday, M equal to Z into Q, Z is equal to equivalent weight upon F. F is Faraday constant. Let me write here. F is Faraday constant. Faraday constant, and its value is 96500 coulomb. So this is what Faraday constant is. Now, what I have done in the next session, I have converted this for zinc. For zinc, this is going to be like mass of zinc dissolving or depositing is equal to equivalent weight of zinc into charge upon Faraday constant. So make this equation 1. Similarly, for copper, what we can write, mass of copper dissolving or depositing is equal to equivalent weight of copper divided by Faraday constant into Q. Now, what we need to do, I have divided both of them. So if that the mass of zinc divided by mass of copper, if you compare them, this is what going to be there, because these two are going to be, you understand what mathematically I have done here. Finally, on a general basis, this equation can be converted for any metal, M1 upon M2. What that mean? Mass of a metal dissolving or depositing, right? Divided by mass of another metal dissolving or depositing is equal to the equivalent weight of the first metal divided by the equivalent weight of the second metal. So this is what the second law is. This is really, really important, not for the board perspective, but also for the competitive perspective like JEE and NEET also. So I hope you have understand everything about. In case there is anything you want to say, there is anything you want to share, comment below and let me know where it's something I need to make again. And with that, I must say I've come to the end of this video. I would say thanks for watching. Take care of yourself and take care of everybody else out there who care about you, and just be honest to who you are and be loyal to who you are, or anyone you care, you must be loyal to them as well. There is nothing like you pretend to be something else, you are something else. What I believe, what you pretend, what you be, that's exactly the same thing. So you need to concentrate on that. That's it. Thanks for watching.